The challenge of square roots of negative numbers was a vexing one for mathematicians for a long time. It just did not seem right that that should be a showstopper. And so what that led to was the creation of the imaginary unit I. So lowercase I is going to be used to represent that for us. And so I is defined as being the square root of negative 1, which then means if I square it, well, a square and a square root cancel each other out, so we end up with I squared equaling negative 1. And so it's not a real number, it's imaginary, so it's outside the boundary of numbers that we have studied to this point. It's in a completely separate circle from the real numbers, if we want to think of it from a Venn diagram perspective. But it's now the tool that we're going to use when we want to solve or simplify an expression or solve an equation over the set of complex numbers. So if we're just solving over real numbers, then the imaginary piece, we don't worry about it. But if we're solving over the set of what we call complex numbers, which includes all of the real and all of the imaginary numbers, then we have a means of dealing with those circumstances now. And so a complex number is one, like I said, that has a real part and it has an imaginary part. So all of our real numbers, like the number 8, falls within the boundaries of the complex numbers. It's just that the imaginary part is 0. It just doesn't, it's not a piece of it. Likewise, imaginary numbers are a part of the set of complex numbers. If I have a number like 4i, that just means that the real part is 0. So all numbers, real and imaginary, fall within the space of what we call complex numbers. So when faced with something like the square root of negative 15 or negative 27 or the square root of negative 24 x squared y cubed, we're going to simplify these numbers exactly the same as we would have before. The only difference is an early step for us is going to be to separate out the square root of negative 1. So I'm going to rewrite this as the product of the square root of negative 1 times the square root of 15. Now the square root of negative 1, again, we've defined that here as being I, so we're going to replace that with I. And then if we could, we would simplify the square root of 15, but since that can't be simplified at all, we're just going to leave it like this. Now we can write our answer as I times the square root of 15, or if we want, we can write it as the square root of 15 times I. The only problem with this second approach is we just have to be very careful to make sure that that I doesn't look like it's underneath the square root symbol. So it does not matter which way you write it, you just have to be extremely cautious of that feature. The I is decidedly not underneath the square root symbol. But moving on to the second example, if we take the same approach, I'm going to simplify this. The first step is going to be to separate the root negative 1 times the positive 27 underneath the square root symbol. So the root negative 1 is I, and then the root 27, this one I can simplify. I can break this down into 9 and 3, and so then I have a 9, which is a perfect square, so I can take the square root of that and get 3. So this 3 will be trapped underneath the square root symbol, so I can write this as 3i root 3 as a final answer, or again, if we did 3 root 3 times I, that's fine as well. Either approach to writing our final result is fine, just clarifying that the I is not underneath the square root symbol. And then for the third example, again, same idea as we did on the previous, and approaching it the same way once we have separated that root negative 1. So I've got 24 x squared y cubed still underneath my square root symbol with that negative 1 separated out. So I simplify here. I can break this into 4 and 6. So 4 is a perfect square, going to come out as a 2. I've got this x squared. I can divide that exponent by 2, so that means I'm going to be able to get an x on the outside. I can do the same thing with the y cubed, divide that exponent by 2, so I'm going to get a single y on the outside, but I'm going to have a y still trapped, so I still have the 6 that's trapped. I've got the y, leftover y that's trapped, and then of course we don't want to forget that we separated out this root negative 1, so I'm going to have that as a part of my answer on the outside of the square root symbol as well. So we've got, we can clean that up a little bit, so we've got the square root of 6y, and then we have 2xy times I on the outside. So in the next example here, we can see we've got 4i times 3i. So we have two imaginary numbers that are multiplying each other. So they've already been cleaned up from square root form. So I'm going to multiply these together just as if it was 4x times 3x. So it's going to be 4 times 3 is 12, but instead of x, I'm going to have I squared. Hopefully recall from the previous slide that I squared is defined as being negative 1. If I is root negative 1, if I get I squared, then I'm going to have negative 1. So the answer here, 12 times negative 1, is going to be negative 12. So we can see that when we multiply two imaginary numbers together, we ended up with a negative real number as an answer. Now the next one here is one where we're going to have to take a great deal of caution in how we approach it. So we don't want to combine this into, oh, negative 5 times negative 20 is going to make positive 100 underneath the square root symbol, and so then we just write our answer as 10. What we need to do is separate out the negative root negative 1 from each part of the expression. So I'm going to rewrite this as root negative 1 times root 5 times root negative 1 times root 20. And so now I've got root negative 1 and root negative 1. Those are both i's. So I'm going to replace each of those with I times I. So I'm going to have an I squared hanging out here, which we'll deal with in a minute. And then I can go ahead and combine together the 5 times 20 underneath the one square root symbol so I can start to simplify. And indeed, hopefully we see that that's going to equal 100. So I've got I squared times square root of 100. Normally we don't want to multiply those numbers together, but just factor tree. But since I can see that it's going to equal a perfect square, I can take the square root of 100 and get 10. And then again, just like we saw in the previous example here, I squared is equal to negative 1. So I have 10 times negative 1 here. So my answer on this is going to be negative 10. And so you'll notice that's quite different than if we had just said, oh, multiply the square root of negative 5 times the square root of negative 20, negative 5 times negative 20 equals 100. And so we would have gotten positive 10 as an answer instead of negative. So we always, always, always have to separate out the root negative 1 from any imaginary number that we have in a given problem.